Pigments are the building blocks of all paintings. Paradoxically, they are often left out of color theories. To be honest, as a painter, it doesn't matter if you don't know any theory. It doesn't matter if you have never seen a single color wheel, as long as you have a good understanding of your pigments. This is how many painters proceed, by experience. Familiarity with colors from pigment mixtures is the best way to instinctively understand color theory. Nothing can replace experience. However, knowledge can also help you avoid some mistakes, so let's see what you need to know about pigments. First of all, let's talk about what pigments are not: dyes. As a painter, you use pigments, not dyes. The difference is that pigments are fine particles not soluble in water. The pigment does not react chemically with the material, and unlike dyes, which are soluble, pigments are in a powder form and they need to be in suspension in a medium to be used for a painting. Each pigment has a unique color code. The P means pigment, and then comes the first letter of the color, Y for yellow, R for red, B for blue, etc. The number following the two letters is the specific code that the pigment has received in this category. This naming system makes things more clear, but keep in mind that there is no unified system. There may be differences from one manufacturer to another. The same pigment sold by two different manufacturers may not have the same appearance or the same composition. They may look very different depending on the manufacturing process. Although this can sometimes create confusion, this variety is an opportunity for artists. It's just more choice. Paint can be made of a single pigment or be a blend of multiple pigments. Artists generally prefer to use single pigment paint tubes. It's not necessary to choose only single pigments. Some blends can also be useful. It all depends on what you need to do. Some more expensive pigments sometimes have cheaper alternatives. Manufacturers label these tubes as hues. For example, cadmium yellow hue is not made with real cadmium, it's an imitation. A very important property to check on the label is permanency or light fastness. Some pigments may fade away or change over time. To ensure that your paintings remain the same, you should check the light fastness. There are two rating systems: the ASTM, which is a standard system, and a rating system that's specific to the manufacturer. The ASTM goes from 1 being very light fast to 5 very fugitive. Manufacturers also have their own standards and their own rating systems. These can be letters, small stars, number, or even words. The opacity of a pigment is mainly determined by its chemical and physical structure, but the manufacturing process can play a role in it. This is why the same pigments do not always have the same opacity depending on the brands. An opaque pigment has a high covering power, while a transparent pigment allows light to go through and acts as a translucent layer. There is usually a small square on the label. If it's completely filled, it means that the paint is opaque. If it's empty, it means that it's transparent. Paint can also be semi-opaque or semi-transparent. As you probably know, not all pigments have the same coloring power. Some are very powerful, and some others are naturally weak. This property is called tinting strength. It is not a sign of poor quality. It just comes from the nature of the pigment itself. Be careful, the tinting strength is not technically the same as chroma, although the two notions are linked. The most powerful pigments in their raw form are usually very dark, like phthalo green for instance, which also means that their chroma in this state is quite low because they are very dark. Yet as soon as they are mixed or as soon as they spread, their coloring power is really revealed. Another pigment, for instance, like cobalt violet, has a relatively high chroma on its own, but it is extremely weak when mixed with other pigments. The tinting strength of a pigment is determined by its ability to maintain a high chroma despite the addition of white, or by its ability to dominate a 50-50 mixture with another pigment. Pigments with low coloring power can be used as a mixing base, while very strong pigments can be used in very small quantities to bring character to weak mixtures. The binder or medium is the vehicle used to spread the pigments and allow them to dry to form a solid layer. The solvent or diluent is a liquid used to spread the pigments and bring fluidity to the paint without adding any binder. The solvent evaporates after spreading on the surface. Depending on the techniques, binders and solvent differ. The binder and the solvent can have an impact on the aspect of the colors. Thus, a certain pigment in a water-based medium will not necessarily look the same with oil. The difference lies mainly in how glossy or matte everything looks, as well as the degree of opacity or transparency of each technique. Inorganic compounds contain minerals, such as metals like cadmium, cobalt, and iron, while organic compounds are made up of carbon-containing molecules, such as those found in plants. Organic and inorganic pigments tend to react differently. Inorganic colors are generally more opaque. When mixed, they tend to mimic the tones of the natural world more closely. This category of pigments can often be used as a mixing base. Organic colors are generally darker, more vivid, and more transparent than mineral pigments, and they tend to produce more intense mixtures. Due to their natural translucency and strong tinting strength, they are better used in small quantities. These two types of pigments can of course be mixed. Lakes are pigments produced by precipitating a water-soluble dye with an inert material called mordant. The dye and metal salts are brought together to allow the dye particles to stack and form a non-soluble precipitate. This process makes a dye usable in painting. Manufacturers don't always mention which pigments are lakes, but they can be recognized by their transparency and particular brilliance. They are generally interesting for glazes and watercolors. Not all pigments have the same drying time. Of course, this criterion is only noticeable for slow-drying techniques such as oil painting. The difference in drying time is due to many factors: the chemical composition, but also the amount of binder. A pigment is not defined by a simple color. Often, two tones can be described: the mass tone and the undertone. The mass tone corresponds to the appearance of the pigment in a thick layer. The undertone is how the color looks in very thin layers and in mixtures. The undertone can have a warm or a cool tendency. Some pigments can be toxic. The most harmful elements are no longer used nowadays, but they are still very well known. This is the case for flake white containing lead oxide, the original vermilion containing mercury, or the old version of emerald green containing arsenic. Fortunately, these substances are now banned. Many safer alternatives exist. chemistry has improved a lot and has made things a lot safer. In addition, regulations have made things safer for artists. Manufacturers are now required to publish the safety data of their products. It can be found online. I encourage you to look at them if you have any doubts on your products. Handling powder pigments and spraying should always be done with a face mask, gloves, and eye protection. If you use your paint tubes carefully and avoid to work in a messy environment, pigments should not cause you any problem. Earth pigments are certainly the oldest pigments we know. They were used in prehistoric times and have survived tens of thousands of years. They have rather dull shades of red, orange, and yellow. Most of the Earth owe their colors to iron oxide, which is present in varying quantities, as well as to the presence of other elements such as magnesium, aluminum, or silicon. They can be in their hydrated form or modified by being burned or calcined. This family of pigments has many advantages due to their natural appearance and excellent light fastness. Plus, they are naturally close to the most common tones in landscapes, animals, and people. Earth pigments are very old colors. They were originally derived from natural clays, which explains the very wide variety of options available. They have the widest variety of names and shades. Natural earth are somewhat rare nowadays, and manufacturers now use synthetic iron oxides most of the time. Natural yellow ochre. Yellow ochre is a yellow iron oxide from natural earth. Synthetic yellow ochre is a synthetic yellow iron oxide, often called yellow ochre, and it is more widely used than the natural pigment. Transparent yellow ochre is a transparent or semi-transparent version of yellow ochre. Raw sienna is originally a natural earth from sienna. Now it is mostly replaced by synthetic pigments. It is darker and less chromatic than yellow ochre. Burnt sienna is a very interesting color, especially for skin tones. There are two versions of this pigment. PR101, which is more transparent and chromatic, and PBR7, which is duller and opaque. Venetian red is a much stronger pigment, and it's a stronger red and less orange than burnt sienna. It's a very powerful pigment due to a high pigment load. English red is very close to Venetian red. It's a little bit more subtle though. Indian red is a slightly duller version of synthetic iron oxide. Mars red or Mars brown are alternative shades of synthetic iron oxide. Transparent red oxide is a transparent version of red iron oxide similar to transparent burnt sienna. It's useful for complexion and glazes. Natural red ochre or natural red iron oxide is generally less versatile than PR101, but it's a natural pigment. Raw umber is a classical pigment, still essential today. It's a very dark orange-yellow with a low chroma that can be greenish sometimes. It's a very fast-drying pigment. It can be semi-opaque or semi-transparent. Burnt umber is the darkest earth and one of the most essential pigments. It's a red-orange-brown with very low chroma that can be used in many situations. It's a very fast-drying pigment that can be semi-opaque or semi-transparent. Van Dyke brown, also known as Castle earth or Cologne earth, this pigment is a pigment that was originally a dark brown earth containing peat and coal residues. It's not considered stable, and nowadays it is replaced by blends of black and iron oxide. Transparent brown is a dark brown, very close to burnt umber. All earth can be useful, whether transparent or opaque, natural or synthetic, red, orange, yellow, or brown. They naturally work with most landscapes, skin tones, and even vegetation except for green. They could be considered convenience pigments, which means colors that are already close to convenient shades and that you don't have to get yourself by mixing. But I think that they make a category of their own. They are extremely reliable. They are also inexpensive and they age extremely well. So it is, I think, essential that you have some at least at your disposal. That being said, it's not necessary to have them all. You've seen that there is a wide variety and it would be tempting to get them all, but it's absolutely not necessary, it's useless. A good yellow earth, as well as 1 or 2 good red and brown, are enough for most paintings. Personally, I use yellow ochre, burnt sienna, Venetian red or English red, which is very close, as well as raw umber and burnt umber. Cadmium red, like all cadmium-based pigments, can be adjusted chemically in the manufacturing process to get all sorts of different shades, more or less dark, orange or pink. It's a very bright red, opaque, which is very strong in mixtures. It is a slow-drying pigment. Naphthol red is an intense, transparent red. Quinacridone red is an organic synthetic red that draws towards magenta. It has a wide variety of shades and nuances. Pyrrole red is a very intense, semi-opaque red that can effectively replace naphthol or cadmium. It's the pigment that's used for the famous Ferrari color. It is semi-opaque and it is a very strong pigment. Alizarin crimson is an anthraquinone lake extracted from madder, a carmine red shade that draws strongly on magenta. It's extremely useful for skin complexions. Unfortunately, the original alizarin crimson is a very fugitive pigment, so you should always prefer a more permanent alternative. It is transparent, it has a wonderful translucency, and it's almost a legendary pigment. There are many versions to replace the genuine alizarin crimson with a less fugitive pigment. A synthetic anthraquinone can ideally replace the genuine alizarin crimson. It does not necessarily have exactly the same hue, but it works in the same way. It should always be preferred to the genuine pigment. It is just transparent and it works wonderfully. This pigment is an alternative to genuine carmine from natural madder. It's a red tending towards dark, deep blue. It's a transparent and very profound pigment. Transparent red ochre is a transparent red, less orange than PR101. It's transparent and has an excellent light fastness. There are many red pigments and they have a lot of variety. They come in all forms and offer a lot of choice. Our vision can detect some very subtle nuances in this range. There are 3 main words that artists need to know. Crimson defines a red that has a violet or magenta undertone. Scarlet is a bright red with a slight orange tendency. And vermilion is a deeper, a little bit darker and slightly more orange red than scarlet. Red is part of the traditional artist palette and holds a central place in it. Actually, it holds a central place in the history of art altogether and in our culture. In one form or another, red is essential. Warm pigment by excellence, it can be used in very small quantities and have a significant effect on all mixtures. To make a red pigment lighter, use titanium white and make it darker with a mixture of burnt umber and permanent alizarin crimson. Cadmium orange is derived from cadmium yellow. It exists in many nuances, from the most yellow to the most reddish. Perinon orange is a synthetic organic orange with a reddish hue. Quinacridone orange is a deep reddish orange comparable to a very chromatic burnt sienna. Benzimida orange is a yellowish orange with average covering power. Pyrrole orange is a very chromatic orange with a reddish hue. It's a very strong pigment in mixtures. Despite the omnipresence of orange shades, orange pigments are not essential for a balanced palette. There are many oranges in the world, but they are all very dark and very low in chroma. They are called brown. Brown is not a hue of its own. It's actually a dark, low chroma orange. Thus, the only essential orange is brown, if we can call it an orange. It is not necessary to have an orange paint tube for your palette because a mixture of red and yellow works well enough. It is easy to obtain by mixing, cadmium yellow and cadmium red, and you can get an orange that has almost the same chroma as a cadmium orange. If you get an orange paint tube, it is therefore only for convenience. Orange can be made lighter with yellow and or white and darker with burnt umber. Hansa yellow is a light lemon yellow with a greenish hue. It blends well. Yellow Lake is a unique transparent yellow with a strong greenish undertone and a high tinting strength. Cadmium yellow is a pigment with a very good consistency. PY37 is a reddish tint, while PY35 has more a lemon tint. It comes in a wide variety of nuances. It is very opaque and has a good covering power. Diarylite yellow is a light and deep yellow with a slightly reddish undertone. It's often used as a cadmium substitute or to replace Indian yellow, which was originally made by warming the urine of Indian cows fed on mango leaves. Benzimida yellow is a light yellow with a lemon hue. It blends well with greens and oranges. Chromium yellow titanite is a pale yellow with a light enough chroma and a slightly orange hue. It can be a good substitute for Naples yellow. Yellow is a very unique hue. It is special because it doesn't really have a dark version. Think about it. What is a dark yellow? The fact that it's so hard to imagine is related to the physiology of our visual system. Yellow corresponds to wavelengths that greatly stimulate the senses in the retina. A yellow to be truly yellow needs to be very light. We can see here that the maximum chroma is reached for the lightest value. Quite often, dark yellow is created by shifting to orange. As we can see in the spectrum of visible light, yellow has a very short range. The slightest mixture immediately makes it look either orange or green. To be used as a primary, a yellow pigment must therefore be exactly halfway between yellow-orange and yellow-green, not too orange, but not too green. And this balance is more important for yellow than for any other hue. Of all the primary pigments, yellow is the only one that cannot actually be obtained by any mixture. The complement of yellow is blue-violet, and ultramarine violet can play this role. Yellow is an excellent option for lightening mixtures without adding white. Titanium white can be used to make yellow lighter, and a mixture of orange and burnt umber can make it darker. Phthalo green is a very deep blue-green color, very intense in mixtures and extremely dominating, maybe the most powerful pigment. Chromium oxide green is a dull yellowish green used in army camouflage. It is very good for foliage. Viridin is a transparent inorganic chromium green. It's a transparent green that's sometimes called emerald green. Green earth was used during the Renaissance for green underpaintings called verdaccio. It comes in a wide variety of natural shades. It's a semi-transparent and it's a very good green, but it's a rather dull green. Phthalo green yellow shade is a green that can be more or less blue or yellow with a very strong tinting strength. Green is a pigment that many artists avoid. This might seem surprising considering that green is the hue to which our eye is most sensitive, and it's also the most widespread in nature. But the green of chlorophyll is a yellow green, very close to yellow and quite far from what could be called primary green. This means that most of the green that need to be painted for vegetation and foliage can easily be made with mixtures of blue cyan and yellow. Paradoxically, deep green pigments such as phthalo green are not very well suited to paint foliage because they are too green and too chromatic. For leaves, it's better to use a rather dull yellow-green. On the other hand, apart from foliage, greens can be very useful to bring a lot of variety to shades where they would not be suspected. Green pigments should not be limited to vegetation. Our modern era is full of opportunities to create surprise with green pigments. If you find that the greens that you're using are too strong, they can be neutralized by rose or magenta pigments. For instance, phthalo green, considered to be one of the most intense pigments, can be somehow tamed by its complementary quinacridone rose or quinacridone magenta. Green can be made lighter with yellow and or white, and it can be made darker with a mixture of ivory black and phthalo green, which is naturally dark. Phthalo turquoise, like all members of the phthalo family, is a very chromatic, intense, and dark turquoise blue. Cerulean blue is a light cobaltine blue that can be more or less greenish with a relatively low covering power. It's an opaque pigment that can be useful if you need a blue that draws more towards cyan. Cobalt chromite blue is a greenish blue that can go from green to blue cyan or turquoise. Cobalt teal blue is a blue-green ranging from yellowish to cyan turquoise blue. It's a very useful pigment as a complementary to red and orange. It's a very opaque and light pigment that's quite useful for mixtures. Cyan is a color that's difficult to define because it's not really anchored in our culture. Very often, we just talk about light blue. Sometimes it's called teal, aqua blue, electric blue, or blue-green. It's not clear exactly what cyan is. Turquoise is maybe the word that describes cyan the best. It's not exactly cyan, but it's the closest to it. If we look at the spectrum of visible light, we see that cyan, like yellow, has a very narrow range. Caught between blue and green, cyan is a very underappreciated color in my opinion. Cyan works great as a complement. It is both the visual and the pigmentary complement for red, red-orange, and red magenta. So cyan is the ideal color if you want to neutralize a red that is too strong. Not all pigments can play the role of cyan. In my experience, cobalt teal blue is the best light opaque pigment, while phthalo turquoise is the best dark transparent pigment. Cyan is made lighter with titanium white and darker with a mixture of ivory black and phthalo turquoise. Phthalo blue is a very intense and deep dark blue that can easily dominate the mixtures, as any phthalo. Prussian blue is a synthetic inorganic blue with undertones that can draw on green. It's a transparent blue that has a good light fastness and high tinting strength. Cobalt blue is a medium mineral blue which may have a greenish hue. It is semi-opaque. Ultramarine blue is the chemical equivalent of lapis lazuli blue, formerly known as ultramarine because it had to be shipped by boat from Afghanistan. The synthetic PB29 pigment is a lot less expensive to produce and contains less impurities, so it's an excellent blue, both deep and intense. It comes in deep or French version, which is darker and slightly more violet. Ultramarine blue is very useful to create black, and it's a pigment that's essential to any palette. Blue is essential and unique. It's unique because it can be both very dark and very chromatic. Thus, just as yellow can be called the closest pigment to white, blue can be called the closest pigment to black. In fact, most blue pigments are so close to black that some artists replace blue with black on their palette. This is the case of Swedish painter Anders Zorn, known to have completed many paintings using only white, yellow ochre, vermilion red and ivory black. The darkest blue pigments, such as ultramarine blue, can be mixed to produce fairly intense blacks or simply to darken mixtures. Blue is complementary to yellow-orange, which makes it an interesting complementary color for skin tones. Blue is made lighter with titanium white or a light turquoise blue and darker with ivory black. Ultramarine violet is a dark blue violet close to ultramarine blue but with shades ranging from blue to reddish. It's transparent and has good light fastness. Manganese violet is an inorganic violet with a low coloring power. Quinacridone violet is a synthetic purple that can have many versions depending on the manufacturing process. It can be light or dark. It is always transparent. Violet is rarely used. There are not many pigments in this category, and most of them are not very practical to use. Plus, these shades are not very present in our environment. That's why very few artists include them in their palettes. In English, we can distinguish the word violet, which is one of the wavelengths of the visible spectrum, from purple, which is a mixture of red and blue. Violet draws more on the blue side, while purple is closer to magenta. Contrary to a widespread belief, the best way to get a purple without a specific pigment is not to mix red and blue, because this gives a rather dull and dark purple. You should prefer a mixture of cyan and magenta for a very chromatic and light purple. Purple or violet can be made lighter with white and darker with a mixture of ivory black and alizarin crimson, and if needed, phthalo turquoise. Cobalt violet is an inorganic synthetic purple, ranging from magenta to purple blue. It is very weak in mixture. It's the opposite to phthalo green. It's probably one of the weakest pigments. Quinacridone magenta is a variant of quinacridone violet. It's a very good pigment if you are looking for a magenta primary. Quinacridone rose is a quinacridone pigment that can be used also as a magenta primary. It is also transparent and it's a bit lighter than transparent magenta. Magenta is a family of pigment that has recently received a name, but has always been known as either crimson, pink, rose, or even violet. It is the only extra spectral color, meaning that it does not exist in the form of a single wavelength, but it is only perceived as a mixture of violet and red wavelength. It's the missing link, the hue that allows to close the color wheel. It's a very useful color because it offers blends that vermilion or scarlets cannot provide because they are too orange. Historically, the role of red magenta has been played by alizarin crimson. It's a pigment that's quite far from ideal magenta, but whose mixtures draw towards the magenta side of the wheel. So it's generally sufficient for portraits. Generally, you don't need to go very far in terms of chroma. Magenta is still not a very clearly defined color because it's not part of our daily vocabulary. In digital technology, magenta looks like this. In additive mixing, it's a mixture of red and blue light. Technically, the best pigment to match this hue would be cobalt violet. But cobalt violet is not an ideal pigment for painters because it is very weak and it doesn't bring much in terms of mixtures. For painting, the most useful pigment to act as magenta is probably quinacridone rose or quinacridone magenta. A magenta can be made lighter with white and darker with a mixture of ivory black and alizarin crimson. Carbon black is a black pigment obtained by combustion. It's a slow-drying pigment. Lamp black is a carbon black made out of soot. It's a deep black with a brown undertone. Ivory black is an inorganic black obtained by burning animal bones. It can be slightly cool or have brownish undertones. It's a very neutral black. Mars black is an iron oxide black with slightly bluish tones. Perylene black is not technically a black, it's an extremely dark inorganic green. Many artists have a hard time using black in their paintings. As a result, many avoid them altogether. I respect this decision, but it's as if the answer to the fear of drowning was never to learn how to swim. To me, the problem comes from a poor idea of what black paint is. If you think that black is the complete absence of color by definition, you're inclined to think that it could or it should darken everything. But this is not the case. A black pigment is not an ideal black, it's not the absence of color. Most blacks have undertones that have a strong impact on most mixtures. To sum up, let's say that black paint is not a real black, but more an extremely dark blue-gray. And it's important to know that usually blacks tend to make everything cooler. Therefore, black is generally not a problem for darkening blue mixtures, as it comes from the same side of the wheel. But every time you try to mix a warm orange color with a black, it does not only make the value darker, but it also shifts the hue towards the blue side and it messes everything up. For me, black is not necessarily a problem, you just have to understand that it has a cool hue and that it's not capable of darkening everything without changing the hue and the chroma. Black is good to darken cool colors, but to darken warm colors, it's better to use some type of dark brown. In oil painting, the most common black pigments do not dry very well and are difficult to cover. Black is a sensitive color. To be seen as a perfect black, it requires to be very pure, and the slightest touch of another pigment pollutes it. In addition, it can become dull if the surface is matte, and a very small variation in value or brightness can ruin the purity of a black and make it look terrible. If you want to avoid problems, remember this. Black pigments always benefit from being mixed with other dark transparent pigments. At first sight, it might seem silly to mix anything with black because it is so dark, but the reality is that the undertones are essential and they are more important than most people think. Very deep chromatic effects can be created by adding transparent pigments with high tinting strength. These additional pigments can correct the defects of black and give it new qualities. Here are some ideas to complement a black pigment. Black and alizarin crimson creates a very dark red magenta mixture, similar to wine lees. It can be used to paint the inside of ear holes or lip corners. It's especially useful for skin tones where there's absolutely no light. Black and a transparent blue like phthalo blue, Prussian blue, or ultramarine blue reinforces the natural bluish tendency of the black. Black and phthalo green creates a very dark green mixture. Black and raw umber creates a warmer, more neutral black, which dries quickly. It's perfect to create a neutral gray because it allows to balance between warm and cool. Black and burnt umber creates a warm, fast-drying black. Black and transparent red oxide or transparent burnt sienna creates a dark red-orange brown that dries slowly. It's useful if you're looking for a slow-drying alternative to burnt umber. Black and a semi-transparent yellow creates a very dark, dull green, exploiting the bluish tendency of the black pigment. Now here is how to create black without black. These mixtures can be more or less neutral, and this allows a lot of variety. Ultramarine blue deep and burnt umber is the best way to get a neutral black without black. It dries quickly and you can alternate between warm and cool. Phthalo green, blue shade and alizarin crimson permanent is an explosive mixture. The result depends a lot on the shade of the phthalo green. Ultramarine blue and transparent burnt sienna creates a weak black comparable to a dark brown that can be orange or green depending on the proportions. Quinacridone magenta or quinacridone rose and phthalo green yellow shade creates a deep black with blue cyan undertones. Lead white is a toxic lead-based white. It was the only reliable white pigment available until the 19th century. It has very good qualities. Zinc white is a translucent white with undertones that may be slightly bluish. It doesn't dominate too much and allows for subtle lightening. Titanium white is a very opaque, solid, strongly covering white with a very slightly bluish hue. It has a high lightening power and can really dominate the mixtures. It is very neutral and pure. Unbleached titanium white is an off-white with a warm yellowish hue. Titanium zinc white is a mixture of titanium and zinc to take advantage of the best of both pigments. Most titanium white paint tubes are actually a mixture of zinc and titanium. Except in watercolor where white is created by leaving the paper untouched, white pigments are essential to most paintings. Painters can do without black, but white is essential and serves as the main mixing base. Titanium white is an excellent white, strong and durable. Its opacity gives it an important advantage when mixing light colors. Remember this, dark colors benefit from being transparent, and light colors benefit from being opaque. It's impossible to have a transparent white, because white is only possible if most of the light reaching the object is diffused at its surface. All white pigments must be opaque, otherwise they can't be white. And in this category, titanium white is the most opaque. Note that titanium white has a slightly bluish undertone, so it tends to make the mixtures slightly cooler. But this effect can easily be compensated by adding a small touch of a warm pigment. Zinc white is less opaque, so it's also weaker. It lightens without crushing the pigments. It's really good to create light mixtures that keep as much of their chromatic intensity as possible, but recent studies have raised doubts about the long-term resistance of zinc white, and more detailed studies are needed to confirm or refute these doubts. Most white nowadays are made of mixtures of titanium and zinc, which gives a pleasant texture and avoid various problems. After reviewing so many pigments, it's normal to feel a little bit lost. First of all, let me remind you something. You don't need all these pigments. More pigments don't make a better palette. For oil painting, here is a list of pigments that I think are good for all types of subjects. You can use this list if you want to have a stock of pigments that are versatile and reliable. Titanium zinc white, cadmium yellow light, or cadmium yellow lemon, yellow ochre, raw umber, burnt sienna, burnt umber, Venetian red, cadmium red or pyrrole red, permanent alizarin crimson, quinacridone magenta, French ultramarine blue, ivory black, cobalt teal blue, and phthalo green. This list is just a suggestion, so feel free to choose your own pigments. Before each painting, select the pigments that work the best with what you have planned for your composition. Here are some more ideas for palette arrangements, some of which contain additional pigments to give you more options. This is an idea for a classical grisaille palette: titanium white, ivory black, raw umber. A limited warm palette can be created with titanium white, burnt umber, and Venetian red or burnt sienna. A super limited warm cool palette can be created with titanium white, burnt sienna, and ultramarine blue deep. An earth palette can be created with titanium white, yellow ochre, burnt sienna, Venetian red, alizarin crimson permanent, burnt umber, French ultramarine blue. A limited flesh tones palette can be created with flake white hue, Naples yellow hue, vermilion hue, burnt umber, and ultramarine blue. Now this is an idea for a cyan magenta yellow or red yellow blue balanced palette, which sort of takes the best out of both systems. You can use titanium white, burnt umber, ivory black, cerulean blue, quinacridone rose, cadmium yellow light. Here is a 6 primaries palette with the cyan, magenta, yellow, red, green, and blue. So you can use titanium white, cadmium yellow light, phthalo green yellow shade, cobalt teal blue, or phthalo turquoise blue, ultramarine blue, quinacridone rose, or quinacridone magenta, and cadmium red. These pigments can be called the sort of ideal primary colors, if you want to say that. And this is an all-around palette with extended primaries: titanium white, cadmium yellow light plus yellow ochre, phthalo green yellow shade plus green earth, cobalt teal blue plus phthalo turquoise, ultramarine blue plus ivory black, quinacridone magenta plus alizarin crimson permanent, and cadmium red plus burnt sienna plus burnt umber. In this palette, each of the main color has two versions, one which is a very chromatic and one which is a darker or deeper version. The following palette suggestions are inspired by great masters. I don't claim that they are accurate whatsoever. Some painters have left notes detailing the pigments that they used, but even these first-hand sources are not a guarantee. So much has changed since the time of the old masters, and today it would be foolish to pretend to have the same exact pigments. Think of these ideas as more inspirations and not historical truth. And most importantly, remember that using the same colors does not produce the same result. For a palette inspired by Raphael, use flake white hue, Naples yellow hue, yellow ochre, vermilion hue, red ochre, verdigris hue, green earth, and carbon black. For a palette inspired by Titian, use flake white hue, Naples yellow hue, yellow ochre, burnt sienna, vermilion hue, red madder hue, red ochre, burnt umber, transparent brown ochre, smalt, which can be replaced by cobalt chromite blue PB36 or cerulean blue PB35, natural ultramarine blue, which can be replaced by normal ultramarine blue synthetic PB29, and verdigris, which can be replaced by viridian. For a palette inspired by Vermeer, use flake white hue, yellow ochre, vermilion hue, red madder hue, red ochre, brown ochre, natural ultramarine blue, which can be substituted for ultramarine blue, natural indigo, which can be replaced by PB66, ivory black, and carbon black. For a palette inspired by Rembrandt, you can use flake white hue, yellow ochre, burnt sienna, burnt umber, ivory black, and a vermilion hue. For a palette inspired by Rubens, you can use flake white hue, yellow ochre, yellow lake, vermilion hue, madder red hue, red ochre, burnt sienna, brown ochre, natural ultramarine blue, German blue, which is cobalt blue, you can use PB28, ivory black, azure green, which is cobalt chromite green, PG26, green earth, and malachite green, which is PG39. For a palette inspired by Van Dyck, you can use flake white hue, Naples yellow, yellow ochre, vermilion hue, natural ultramarine blue or ultramarine blue, red ochre, green earth, raw umber, coal black, madder red, Van Dyck brown, natural indigo, which can be replaced by PB66, and lamp black. For a limited palette inspired by Anders Zorn, it's not the only palette he used, but he was famous for his limited choice of colors. Just use titanium white, yellow ochre, vermilion hue, ivory black. For a palette inspired by Bouguereau, you can use flake white hue, Naples yellow hue, yellow ochre, chrome yellow, vermilion hue, madder red hue, Mars brown, Van Dyck brown, burnt sienna, cobalt blue, bitumen, which can be replaced by a modern substitute, and ivory black. For a palette inspired by Claude Monet, you can use flake white hue, cadmium yellow, vermilion hue, madder red hue, cobalt blue, and chrome green. And finally, for a palette inspired by Van Gogh, you can use flake white hue and zinc white, chromium yellow, zinc yellow, Van Dyck brown, you can use a modern substitute, vermilion hue, madder red hue, cochineal red, you can use a carmine substitute like PR176, cobalt blue, Prussian blue, ultramarine blue, cerulean blue, and viridian. Here's an exercise you can do to learn all about your pigments and understand how they mix. You know that mixing two pigments at 50-50 does not always create an even mixture. Not only does one of the two pigments generally dominate, but their mixture may also produce a very unique result in terms of hue. This is an exercise that will have you waste a little bit of paint in the beginning, but you will be able to keep it as a reference in case you need it later. So in the long term, you'll certainly make fewer failed mixes and save paint overall. Take a leftover piece of canvas that you don't need, or a sheet of painting paper. Use masking tape to create separations and arrange all your pigments to create a double entry table. Here I place the pigments that I use the most frequently. I have the following pigments, and I place them in the same order on the vertical axis. Mix the pigments in equal proportions, for example, half yellow ochre and half titanium white, half cadmium yellow and half yellow ochre, etc. Make sure that you have 50% of each pigment every time. If you work with oil or acrylic, to avoid having to clean your brush too often, you can work with a palette knife or a silicone brush, which is easier to wipe off. You will get a grid that will give you valuable information about your pigments. You'll first see which pigments have the greatest tinting strength among your selection. If you look at the grid I just made, the strongest is clearly phthalo green, because it's the one line whose color is the more dominating. If you follow its entire line, you can see that no other pigment can take over. It is closely followed by cadmium red and Venetian red. Here, for example, alizarin crimson and quinacridone rose are almost identical, so there is no reason to use both pigments together or find another manufacturer that produces them with more variety. Finally, we can observe the degree of transparency or opacity obtained, which can also be very useful.